Beginning of Log 7. This is Carson Isaiah Shen, head of the Mech Propulsion Systems Lab owned and operated by Aegis Mechatronics. This 7th log serves as a rough draft for the Peculiar Robot Contest, or PRC. The Fighting Directed Laser Armament Mech, or Fidlar, is ready for finalization, which will include some minor detailing and protective surface treatments. This is a pilotable mech, but until now we have only been relying on computer analysis for testing sequences. The final critical hardware component required for the Fidlar is the access hatch that allows the pilot to enter the cockpit. We recovered a standard tank hatch from the Mech Propulsion Systems Lab warehouse and combined it with a custom hinge to fit the hull. Leveraging plasma cutting technology, the thick armor can be easily modified, allowing us to weld on the manual access handle. Reinforcements are added to ensure the hatch withstands the rigors of combat deployment. Surface welding would not be strong enough for this application, so sockets are added into the hull exterior for a proper connection. With the hatch installed, the mech is ready for manual piloting exercises. This time around, I'll spare you the details of full disassembly, as we have already recorded the process in previous logs. I say this a lot, but Aegis Mechatronics is pretty old school. That means we still use rivets on our designs. However, there is a time and place for each technique, so we mostly install them where a quick reinforcement is needed on non-functional armor. A total of 338 rivets were used for reinforcement. Subassemblies undergo a calibrated rivet treatment process tailored to their specific requirements. This technique offers a particular advantage for securing small brackets. Riveting provides a permanent, yet separable connection, ideal for instances where disassembly might be necessary in the future, unlike welding, which creates a wholly fixed joint. It is important not to rivet critical armor plating, as the extra hardware can create stressors that weaken the design. After finalizing construction, the mech is handed over to the chemical engineers to work their magic. Rigorous leak detection procedures confirm water and airtight integrity of the hull, critical for crew safety. All components undergo a precisely controlled thermal cycle within a high-capacity electric furnace. This process facilitates both hardening and annealing of the utilized metals, optimizing their strength while minimizing residual internal stresses. As always, Aegis Mechatronics enforces strict safety protocol adherence in accordance with government mandates. Both metallic and non-metallic surfaces are protected with an abrasion and chemical-resistant coating that will prevent corrosion and wear of all systems. The initial layer helps to chemically bind any additional required coatings to the parts being modified. Most components, such as exterior armor plates, receive a standard electrostatic application of powder coating for durability and toughness, while chrome is used on specific parts such as the hydraulic pistons. Following our standard surface treatment procedure, all functional components that may need to be serviced, either in the hangar or in the field, are given special attention. All critical components, including sensor modules, fluidic conveyance assemblies, motor housings, electrical access points, filtration systems, and magnetic latching mechanisms, undergo rigorous individual performance verification. Upon successful completion of quality control inspections, these components receive a unique metallic surface treatment, signifying their compliance with established specifications. Rigorous scrutinization of every surface of every system ensures adherences to the design specifications and minimizes the potential for unforeseen malfunctions in the future. This is by far the slowest part of our finalization procedure, and we are already analyzing ways to accelerate such a large amount of testing. After individual sign-off for each functional component, we make another pass across the mech and begin integration testing connections between related parts. Electrical systems are protected with a special metallic coating that protects against EMP attacks. This gilded coating is applied to the highly specialized and sensitive components and connections that allow system-wide functionality. It is worth noting for the audit that we use a copper-gold alloy, which is both more durable and more cost-effective than using pure gold by itself. The solution has to be manually applied, however, which takes a significant portion of our work schedule to complete. With the Fidlar finally ready for field testing, we apply relevant markings to various parts of the mech, including model name, the contract it was built for, hazard warnings, the manufacturer, and the build number. The implementation of mandated markings makes the mech regulation compliant for live fire testing in simulated operational environments. The Fidlar was subjected to live fire exercises that resulted in minor wear across the mech. The hydraulic legs were put through high-endurance marches over rugged terrain. Small arms fire showed negligible damage to the armor plating. The 6-round missile array and double plasma coil gun were fired repeatedly in rapid succession drills. The auxiliary arms were used to manipulate a variety of soft and hard materials. The primary laser cannon was tested for precision and power against fortified targets and monitored for impacts of atmospheric scattering. Electricals were stressed using EMP resistance tests. All results proved acceptable. The Fighting-Directed Laser Armament Mech is an engineering marvel containing the latest and greatest advancements in mobile armor and energy weapon technologies. Alpha-voltaic battery modules provide a stable, non-explosive energy source capable of cold-starting the nanotronic fusion power core. A photonic emitter in the primary laser cannon increases the efficiency of the collimator assembly. The collimator itself uses tritium gas within a crystal lattice tube. A hydraulic piston with a separate axle clutch provides redundancy in case of failure. High-quality petroleum-based grease is applied to moving mechanical parts to ensure smooth operation. During missions, the primary laser cannon can be securely opened and closed to utilize or protect the laser equipment when needed. Components are secured with standard, easy-to-procure hardware. All electrical plugs are also standardized for efficient repair and replacement. Magnetic latches are utilized across systems, allowing for fast connections. Chrome-plated double hydraulic piston sub-assemblies offer strong locomotive force for movement of the entire mech. Ankle ball joints provide 3 degrees of freedom of motion. Double claw toes allow the mech feet to grapple onto most terrain surfaces. Each leg also has reactive armor protecting the knee joints. The quadruped design has a high carry capacity, and redundancy allows continued operation in case of a limb failure. The LiDAR system excels at producing high-fidelity, short-range images of the nearby environment, regardless of dust storms or smoke screens. The electrical infrastructure for the legs features a robust network of conduits. The front auxiliary arms are useful for manipulating the environment. The Mech Propulsion Systems Lab is confident in its entry for the peculiar robot contest, having deployed its full engineering resources to create a large-scale, high-capability combat platform. As mentioned in Log 1, we've given extra attention to originality, consistency, and detailing as possible. Achieving a mech of this scale again may not be feasible, but Aegis Mechatronics remains immensely proud of this engineering feat. As always, we'll be open to addressing questions or concerns on behalf of the company. Attached is our final showcase. Feel free to leave your comments before the formal audit is submitted later in the year. This is Shen, signing off for the last time. Thanks to our benefactors, a new channel of private communication has been opened. Join the cause for exclusive information. This is the end of Log 7.